Okay guys, so today we want to talk about the transformation with all the trigonometric functions such as sine and cosine. So tangent, cotangent, secant, and cosecant, we'll talk about that tomorrow. So you may notice that the basic form, standard form, alternate, ultimate, things that we talked about in class already. So once again, for those students having a hard time to start with the transformations, so let's do one example like this. So we got y equals -1 plus sine of quantity, 2x plus pi. So you may notice that this one looks like it's kind of like an ultimate form. The one thing that we need to do first, we want to take out the scale factor, which is 2. And then we have x plus pi over 2 remain. And also for that -1 and sine, you can just swap those terms. So start it off with sine of 2 times quantity, x plus pi over 2, and then minus 1. And then from here we can identify the amplitude. So amplitude, which is the invisible 1 right here, and then scale factor, 2. So that means the period is 2 pi over b, which is 2 pi over 2, so which is pi. And then h, horizontal phase shift, it's -pi over 2. And then k, it's -1. So again, we just rewrite it with the ultimate form. So once you identify all the element, we can do the one cycle test. So the best thing about the one cycle test, so this one, once we do the one cycle test, we can find the initial positions and the final positions of the graph. And you may notice that the parent graph of sine, it's always going from 0 to 2 pi for one cycle. So that's why for the one cycle test, we started with 0, less than or equal to the quantity, and then it's less than or equal to 2 pi. And then for the blank, we want to put in 2x plus pi. And now we want to solve for x. Subtract pi each side. So we get negative pi, it's less than or equal to 2x. It's less than or equal to pi. And then divided by 2. So now we end up with negative pi over 2, less than or equal to x, less than or equal to pi over 2. And not a good thing about doing the one cycle test. So once you find the initial positions, final positions, so there's no need to worry about the period and the phase shift. So pretty much once you do one cycle test, it takes care of the period, the phase shift, and also shows you the initial positions and the final positions for the graph. So now let's sketch the graph. Okay, so we need the x-axis, the y-axis. Again, x-axis, that's the radian. So started with negative pi over 2, and then finish that at pi over 2. And the midpoint right between that, the initial positions and the final position, is always 0 here. And then half of the distance right between negative pi over 2 and 0 is negative pi over 4. Over here, positive pi over 4. And they're all symmetrical. So for sine, it's a roller coaster curve. So we started at 0. And then the next position, it goes all the way up to 1. Because that's the amplitude. And then the next position, it goes back down to 0, and then -1, and then 0 again. And then simply connect the dot. And the reason why that I use the dotted curve, because this one is just the parent graph. So there's no vertical translation involved here yet. And now, k is -1, so that means we need to subtract all the positions by 1 unit. So 0 minus 1. -1, and then 1 minus 1, which is 0, and then 0 minus 1, -1 again, and then this one, it goes all the way down to -2. And then the final position, it goes all the way back to -1. And now, for all the dots, disconnect them. Again, it's going to be the exact same kind of figure. It's a roller coaster again. And here's one cycles of the function. Thank you for watching the video today.